So hello everyone. Today we are solving maximum subarray. It's a leetcode medium question. It's a very famous question because of the Candace algorithm. So whenever a question is having a named algorithm or something like that, so it gets very famous. So this is one of that particular questions. So let's start with the question. So I'll read out the question first. The question is like we have to find the subarray with largest sum. So what is subarray is that for any particular array, like in the first test case, this is the first test case we have. So for the first test case, we want to find that how many subarrays could be possible. So if I say like a subarray is something we have a continuous arrangement of the elements, such that when we say that it is continuous, so we obviously mean that there is no element missed. So if we are choosing one index as 0 and another index as 6, then we are saying that every element between them would be considered in it. Okay, so like -2 to -5, every element would be considered. That then it means that we are having this particular thing as subarray. It's not like that we are considering from -2 to 5 and we are not considering 4. Then it comes to be a subsequence, not a subarray. Okay, so subarray ko agar if we want to describe in a very simple language, so we will be saying that anything where we can draw a line, continuous line, and in that continuous line every element is getting covered, then we are saying that it is a subarray. Now this line can have a starting point and ending point between that range, so and any element could be that in that starting point and ending point, but yeah, it should be in range that is 0 to n, which is the n is the size of the array. So yeah, I have drawn some arrays over here, that is subarrays. We have some subarrays starting from the index 0, that is -2 element, and we have this in the range. Then we have starting it from -1, it comes out to be third index element. So here we are having few elements. So you can see like this is the way we are doing. So here we have to be choosing three things. First thing, whenever we are going to generate a subarray, we need to choose a starting point. Now for a subarray which is having a size from 0 to n, we can choose any index. So this comes out to be n options we have. So we'll be having n options, so we will be iterating n times. Then for j, we would be having I to n, and that against in worst possible case comes out to be n, so that's here n. Now once we have found that particular subarray, we have to find the sum. Now when we are finding the sum, we can have it in n times, because at worst possible case the subarray maximum length could be the array itself, that is the n. So this time complexity comes out to be n cube, and that's not a very good time complexity, and you will definitely ask the interviewer to, like, an interviewer will definitely ask you to optimize this and more further. So like if you guys do CP, then you might know that we can actually eliminate this particular thing, this particular line of n times. That is, we can use a subarray. So instead prefix sum, what prefix sum does is that instead of calculating the sum in O of n, we will be calculating it O of 1, that is constant time. The reason is that we will be pre-computing this in a array, that is prefix array, and through that we will be able to do it in O of 1. So I'll show you the code of snippet code of the array, the question where we are first generating the starting index, then we are generating the ending index, then we are iterating to find the all sum through that particular subarray starting from index I to j. So here we are able to find the maximum sum, and using the maximum function, here we are finding the maximum sum. Here we are updating the sum, so here we are getting the sum of the array we are choosing from index I to j, and then we'll be returning it. Okay, now the second form of is that, as we discussed, that we will be eliminating this O of n by introducing a prefix sum. So we will be introducing the prefix sum. So what prefix sum does is that when we are talking about this particular index, then when we are talking about this particular index, then we will be calculating the sum of index till starting to this particular index. So if we want to find a sum between this I to this particular j, then what we'll be saying that subtract this particular prefix sum till that index I till the from the this particular j. So what will be left out is this, that is the sum we require. So we can find this particular thing in O of 1, and that would boil down our time complexity to O of n square. So but yeah, when we are talking about prefix sum, we have introduced a space complexity of O of n, because it would be an array, and array takes O of n space. So yeah, that's all. Now I guess O of n square is not even that good. The reason is that in the question we are given 10 raised to power 5, and 10 raised to power 5 multiplied by 2 is 10 raised to power 10, and which is a very high complexity, and that time complexity is not allowed. So we'll be finally jumping out to the named algorithm, that is Candian's algorithm. Yeah, and to be very honest, then whenever a question comes out to be with the named algorithm, then this question is most likely to be asked in the interviews, and it's already very famous question. It has come in Amazon, in most of all the FANG companies, Amazon, Google, Meta, which is now previously which was Facebook. So yeah, when we talk about Candian's algorithm, so it's a greedy approach. It would be very intuitive to you. So let's start with it. So what we'll be doing, that we'll be having the sum, and for every index we are coming to, while iterating, we will be asking that are you able to contribute to the maximum sum. Then if that thing is able to contribute, then we'll be adding it, otherwise we'll be making it 0. So for example, we'll be saying that when we are coming to -2, we say that we have maximum sum over here, and it is around 10. I'm just saying it 10, we are letting it, we really don't know that it is 10 or not, but for explanation purpose I am saying this. Now when you say that -2 is over here, then we ask -2 if you would be if you would be added to the subarray, then will you be able to contribute to it. Then -2 would be saying if the sum is 10 and I am -2, then I'll make it 8. So in a way I am decreasing the maximum sum. So I guess like I won't be able to contribute, you can go ahead without me. So when we are saying I am going ahead without you, then we are not considering this particular element, and whenever we don't consider it, so we would if we don't consider this, then we mean that all the elements behind this we won't be considered. That is the basic rule of a subarray. So all the elements behind it, right now there is no element, but if there would be previous element, then we won't even considering that. So every time we don't choose the element, we make the sum 0, because we just don't choose this particular element, but we just not ignore this particular element, but also the elements previously occurring. So like any element behind this particular index won't be considered, because this is the rule that I guess I have already put a lot of pressure on this particular point. But yeah, whenever we chose an index and we choose it, then we mean that every element behind this won't be chosen, which makes the subarray, which is the basic rule of subarray, and that's how like the sum out comes out to be 0. So when we are making the sums to 0, that is the basic gist of this particular question. Okay, and now we come to the index to 1, and here we ask that 1, are you able to contribute something? So 1 will be saying, yeah, I'm a positive number, and if it will be 10, I'll be adding up and I'll be making it 11, so I can contribute something. So we'll be saying, okay, good, we'll be adding you. Now we'll be saying -3, are you able to contribute something? So -3 will be saying that by adding the sum from my previous and me, I am able to get the maximum sum as -2. So -2 when added to 10 would making it again 8. So he'll be saying that no, I don't need to come with you guys. And whenever I drop off, I'll take all the elements behind me, that is my neighbors. So you can go ahead with the sum 0. So we'll be saying okay, we are going ahead. Then we come to 4. 4 will be saying yeah, I'll be giving a positive sum, so you can consider me. Then we'll be saying okay, 4, we have considered you. Then we'll be saying -1, are you able to consider? Are you able to contribute something? So -1 would be saying that yeah, I am not able to contribute because I am negative. But yeah, my previous elements are already contributing and they are contributing hell lot. That we even together won't be able to uh, make you give you a loss. So we'll be saying that okay, if you are not able to give a loss and you are giving something positive, then we'll be considering you in the way the people behind you as well. So we'll be saying okay, then I am contributing a power sum of 3. So we'll be saying okay, that's great. Then we'll be coming to 2. 2 will be saying yeah, I'll be contributing 2 as well as my previous elements are contributing 3. So I'll be giving up a total 5. And we're saying great. Then we'll be coming to 1. Then we'll be saying that 1, are you able to contribute? So 1 will be saying that I am contributing 1 and elements before me are also contributing 5. So we'll be together contributing 6 to the answer. So we'll be saying that's great. Then we come to -5 and -5 will be saying though I'll be contributing negative, but my previous elements are contributing greater than me, so I'll kick out to be 1. So we'll be saying okay, great, no issues, we can take 1 and we can go ahead. Then we go to 4 and we'll ask that 4, are you able to contribute something? 4 will be saying that I am the last element and I am having a I'll be contributing 4 and previously elements are contributing 1, so you can consider that I am having 5. So we'll be saying the great. Now we have got the maximum sum as 6 and that's the answer of this. So here we are always greedy to find the solution, and we are always expecting that if we are not considering this element, then we will be making the sum is 0. That's the main gist of this particular question. And here is the code of this solution, and when we submit it, you can see that it's getting accepted. I have already submitted it. So yeah, it's getting submitted and we are able to find the solution. So in this solution I have done nothing. I have just make it adding the sum and then calculating the maximum sum, and whenever the sum comes out to be negative, then we are just saying that we are making it 0, and we are making it 0, we are saying that we are not choosing any element before it. Okay, so that's all. Still you have any doubt, you can put it in comment section. We will be happy to answer you. Thank you so much.